Hello, hello, hello. Let me see if I can hear myself. Hello, hello, hello. Test, 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 test. Hello, hello, hello. Test, 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 test. Okay, the mic is working. Why'd I get two of these? What did Val like? Oh no, my phone's gonna die. No. No. Before I even started the calculus. Oh my god, my phone's dead. Okay, calculus time. How do I get off that? Okay. First integral of the night or day, I guess. This little beauty. Did I write it down right? I feel like I wrote it down wrong. Let me double check. Ugh. Should it be two? I feel like it should be two. Huh. Mm, no. No. Oh, this is hard. I forgot what it's supposed to be. That's not a good thing at all. Mm, I think I have it saved somewhere. Ooh, Where is the man? Mm, mm. Did I send it to him on iMessage or something? What the hell? Where is it? No, I can't find it. That's sad. Man. Oh, let me do something real quick. Let me think about it. Why not? Okay. Hey, plug it in. Ugh. Ooh, I could just look for. I think I might have it here. Okay, I do. Alright. Yeah, I did need it too. Aw, shucks. How am I gonna fit that? I don't even want to know. Like this? Oh, the pen's off now. Alright. So this is the first integral of the night or day, whichever you prefer. Um, hmm. Starting off, infinite. Identify that. There, I don't need to put the dot 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 there. I need to put it here. Oh my god, this is so unesthetic though. I hate when I always do this. Okay, and now we can identify, is this also y? So it's like recursive, I guess. Now from there, we low key, that's way too large. How does one erase? Oh, opacity's all the way down. Hello. Why is this such a weird, what eraser is this? Erase with current brush? Oh, heck no. It's better. Okay. From here, square both sides. That's what I should do. Oh, no. What am I doing? What? I said square. And now, from from here, I can plug that into there. So I can rewrite this. Fancy integral. Okay, I don't like how that's not straight. E to the 3x plus e to the 2x. And then this whole thing's y. But it's actually also y squared. Wait, did I even write the integral right? Huh? Let me go check again. Two times square root of everything, e to the 3x plus e to the 2x times square root e to the x plus times square root e to the x plus. Okay, is that what I have here? It is, okay. Go back. Okay. Alright, I got the integral right this time. Erase this real quick. Okay. What was I doing? Oh, this. Don't need it that large. You may be wondering, how can you put in y? You didn't do u sub or whatever, and you're right, but I'm gonna do it anyways. Uh, so from here, I believe, oh, I should probably explain my reasoning. So all I did was I got to this step right here, and then I realized, oh wait, I should probably just plug this in to here so I can get this, right? And so from here, what I'm gonna do is, the reason I did all that, that is a way too small of an integrand. That is way too much of an S. That is also an S. I give up. Too small. I don't give up. Too SE. I don't give up. Good enough. From here, what I'm gonna do is factor out e to the 2x from everything, right? Because these are, the same thing. So that'll leave me with e to the x, because for this one, and this one will just leave me with y. Now remember, what is e to the x plus y? That's y squared. E to the 2x times y squared. And then, because they're both squared, the root cancels out, leaving you with 2e to the x y dx. Now, luckily for us, actually, unluckily for us, I don't know why I said luckily, basically, the issue now is I don't have dy, so I can't integrate. So what I'm going to do is I'm going to go back to here, and I'm going to change this into a quadratic. Because I can do that, because this is an arbitrary value or something, right? It looks like a quadratic, so it is a quadratic. And now, other way around. What was the formula? Let me double check. Yeah, it's only positive, so we only do plus, no minus. 4ac over to, oh, it's a on both sides. I forgot about that. Okay, well, a is 1, c is 1, b is 1. So that leaves us with, oh wait, no, c is e to the x. A's 1, B's 1. So -1 over, or no, A's 1, B's -1. I'm dumb. Well, I could just do this. Not plus or minus, what? Plus 1 squared minus 4 times 1 times e to the x over 2 times 1 again. And that'll just be 1/2 plus, oh, too tall. Okay, that's actually too long. I don't want it that long. Okay, so now you may be wondering, why do we do all that? That's actually so we can plug it into the y, right? Because this is a definite solution in the term of x. So if we plug it into y, we can now integrate this somewhat, bear with me. Or actually, it's not ready to integrate yet, but I'll show you. I'll show you what I mean in just a second. I'll show you why I'm putting it in front of the e to the x in just a second as well. Okay, so now 2's cancel out, and you're left with this. Then you may be wondering, what am I going to do with this? Very simple solution. Which, now that I'm thinking about it, not that simple, but it's very simple. U sub. Right, because it's U sub. So if you do U sub here, you'll get uh, one. No, one can't. What? What am I doing? Okay, so du equals 4 e to the x dx. Or wait, obviously there's no 4 there. Well, oh yeah, by the way, that's why I put the that's why I put the y value in front of the e to the x, so I could do this, by the way. Times 1/4. So now what we're going to do is 1/4 on the outside, 1, 0, 1 plus root u du. Now we apply first fundamental theorem of calculus. Okay. Oh, I forgot something. I did. So we have to actually plug in the new bounds. So at u equals 1 minus 4 e to the 1, that gives you what? Did I do this right? I feel like I did. I should have. I'm pretty sure I did this right. I think when I did this a couple months ago, I didn't do this, chat. I think I did u sub for 4 e to the x, and then I did t sub. I did 2 u subs. I don't know if, wait, did I need to do that? We'll figure it out. So 1 minus 4e is the first bound, or the second bound technically. And the first bound would be 1 minus 4 e to the 0, which is 1 minus 4, so 3. So I have to go back here and erase those. Very sad. So, oh wait, how am I supposed to, bro, what? 1 minus 4e is the top, bro, what? That's so much space. It's like mush. It's not 0, it's 3. I just realized, how is that? That's a negative. Huh, interesting. I'm not gonna question it. I guess I could reverse it, but then I'd have to make it negative. I don't feel like doing all that right now. Okay. So 1 over 4 um times u 1 minus 4e to 3, or 3 to 1 minus 4e, plus root u is just what? It's 3 over 2. It's, or 2, it's u cubed over 3, right? Because you do this, this is 3 over 2. It comes down, this cancels out, left you. Okay, yeah. Wow, I'm so good at this sometimes. Watch me get it wrong. I don't even know the right answer. I'm gonna be honest with you. I think I lost it, which would be very sad. So if anyone wants to fact check me, I say anyone, like anyone's gonna watch this. I'm probably just gonna watch it over again. If I'm wrong, I'm gonna tell myself I'm wrong. Um, what would this even be? Okay, 2 root 1 minus 4e cubed over 3 minus 2 times 3 over 3 cancels out. That just leaves you with 2. I feel like, no, I feel like there is another way to do this. I must be tweaking. Let me go check my messages. Or not another way, like a different answer, I guess would fit better. Hmm, not gonna lie. I don't know a better answer. That's a little awkward. I guess I could do that. Okay, so new idea. Low-key, I already forgot. New idea. Go back. We just gotta go back. We gotta go back a couple steps. Here, what we're gonna do is instead of 1 minus 4 e to the x, it'll just be e to the x. Yeah, just normal e to the x. That should still work, I think. I don't know, I haven't tried it. The other answer should be right, but it just looks ugly, so I'm gonna change it. I should probably turn off my room light. It's like 2 a.m., right? 2:23, same thing. Low-key hate MLK, but gotta say thank you for the day off, even though I hate him. Oh, turn off this TV, this is annoying me. So loud. Okay, derive. Low-key dumb. Why is this on vertical? That's annoying. E to the x dx. And now from here, still cancels out. Oh, and the u, almost forgot it again. E to the x, or e to the 1, which is just e. That's just 1. From 1 to e, it'll be 1 plus root 1 minus 4u du. Because du is e to the e times dx. That's e times or e dx. You know, I don't know if I should say times. I'm not a physicist. Forgot the. Oh, I should be a physicist. I should like switch majors. Email them, tell them I got a 3. Tell them I was in the group me. Okay. Um. Another T sub or another U sub. So a T sub. T equals just 1 minus 4u, right? If I do root, if I do the root, no root, no root. Did I forget how to integrate or something? What am I doing? And I'm not gonna change the bounds. I should change the I don't want to change the bounds. You know what? I'm not gonna change the bounds. Um, 1 plus root t dt. Yeah, and this time you have to bring out the 1 over 4 again. Let me erase this. Let me just rewrite it as. But this time we have clean whatever these things are called, bounds. Separation. First fundamental theorem again. Nothing new. Plus. Oh, my mom. Oh, it's 2:30? Yeah, I know it's 2:30. Okay. Uh, Always hating on me. It be your own people too. I'm just gonna put it back in terms of you. So this would be. I mean, this part really it doesn't matter. What was I gonna do? Okay, wait. I already messed up again. So here, what we can do is we can split it, right? Erase this real quick. I keep skipping steps. This is taking me so long. I probably should be asleep. All right, here, E1 1 du plus 1e root 1 minus 4u du. This one we apply the t for, right? There's the other one we don't because we don't really care about it. That one's pretty easily solved. And that one, actually, I will update the thing for 1 minus 4e. Why am I? Okay. Uh, should I simplify it? Nah, that's the first integral of the day. How do I save it though? I don't want to lose this to time. Lose it to time. Talking like it's some unsolvable mystery. It's, it's gonna be some unsolvable mystery in like a year. What am I looking at? Okay. I low key. I got like one more integral in the thinker. And then I have to start Googling them because I don't have integrals saved. I'd be solving too many. Okay. This is the demon spawn integral. Okay, if it can load, alright, whatever. Doesn't want to load, that's fine. Who needed that anyways? What was the one? What was the one that Diddy gave to me? I have to look for it in the Discord then. Mm, 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 mm. Okay, this is just gonna be the hardest one that I know. If my phone doesn't die. Oh, there's the charger. Is it plugged in? I hope it is. It's not! Dang it. Ugh, I have to get up and plug in my charger. I wish I could use this iPad one. Stupid Lightning BC, Lightning BC, what? Integral number 2. This one's a little bit trickier, but you should still be able to solve it, even if you know only the basics of calculus, because it's just such an easy integral. And honestly, if you can't solve it, you might want to give up on calculus now. Did I erase all this? It's a pretty simple integral. Who needs it? Who needs it? Oh, that was so laggy. All right. This is the cool ought integral. It's indefinite. So if I forget plus c at the end, you guys can stone me. Or I guess I'll stone myself because I'm the only one here. Let me rewrite this. I don't like how I wrote all that. And the fact that I ran out of space too. That's also pretty annoying. Okay. Well, now it's at a slant. Voomp. X squared. I don't like that 3. I don't like that 3 either. God. Still at a slant, but no, it's still pretty noticeable. Just gets progressively smaller and smaller. This is really, today is just not my day. That is such an ugly D. Okay. After I'm not gonna try and make it better. That's honestly good enough for me. This is the hardest one I know. I remember this one took me like 10 minutes of straight writing just to solve. Um, Forgot the solution, unfortunately. That would make this a lot easier. Wish I at least wrote it down. I know the final answer, fortunately enough. I think it should be, I think I sent it here. Let's see. Okay. For arcsine x minus 1 over 2 plus x minus 1 times this little square root part over 2 minus 2 over 3 times this little square root part cubed over root cubed minus 1 over 4 x minus 1 times square root part times 1 plus 2x minus x squared plus c. It's a little long, but it's whatever, right? We can do that. It's light work, no reaction. All right. First step. First step. I'm looking at it. I think the first step would be completing the square because that's like low-key can't explain it. But that's just the first thing I feel when I look at this. So we're gonna try it. Complete the square. What was the formula again? It would be like, it should be a 4. I know that. Wait, no, no, no. It doesn't have to be a 4. I could make this, oh, let's say I rewrite it as, okay, 3 plus 2x minus x squared. I can set that equal to negative x squared minus 2x plus 3, right? And then there, I'll add plus 1 minus 1. And then this is just x minus 1 squared. And then we keep that minus 1 out. Or no, no, no. This should be plus. E. Oh, that's too large. I didn't need to erase that part. Did I? Bro, no way. Okay. That goes on the outside. Alright. And then plus 4. Right. And then we just plug that back into here. Or it would be minus. Little sidetrack. The way I write my x's, the reason this is an x by the way, in case it wasn't obvious. Um, the reason I write it this way is because I don't want to have to lift up my finger, like my pen, from the paper. Or I guess there's no paper this time, or pen, but you get what I mean, right? Like I don't want to have to lift it up because I'm lazy, so I just let it drag over when I do the second loop around. So I don't know. I've been told it'll get a little confusing for Calc 3 hasn't really happened, unfortunately so. So, I'm gonna keep doing this. Now we completed the square, and from here, this x minus 1, it's looking like, hmm, say 2 sine, 2 sine theta. Let me write it a bit further away. 2 sine theta. And then from that, what we can do is, we can move the 1 over. And then if we take the derivative, that'll get us 2 cos theta. D theta. And then we can plug this back in, and it'll just be oh wait. It'll be 4 minus root 4 minus 2 sine theta squared, which is 4. Okay, I don't know why I wrote that one so small. 4 minus 4 sine squared theta, which is, no, actually that's just 2 cos. Right, because how was I gonna explain how that's 2 cos? Oh, oh, I'm yeah, that's my bad. Basically, I can't think of my explanation again. I just know this is true. I forgot why. Oh, I think it should be. I'm not even gonna guess on the explanation. I'm gonna be honest with you. God, why isn't there? Bye, bye. Why you? Bye. Why you want you explain? I literally just did this. How did I forget why it would be this? I just did the work. What am I doing with my life? Anyways, just trust me on this one. Oh, this should be a squared. Just trust me on that one for now. Oh, an x squared. We're gonna square this to get x squared. We're just gonna plug in that instead of squaring x. Times 2 cos theta times 2 cos theta d theta Or I guess I shouldn't put the d theta inside the parentheses because that's not, you know? That's really slanted. Again, I, dude, we were just over this. Why'd you do it again? I could wait. I could always just do that, and then that'll probably help with my problem. Okay. It it helped a bit. It's not I gone. Gone. We're gonna keep doing it. Yeah, no, it's still just retry again. Yeah, that's straight enough. Let's go. That was so sick and cool and rad. Now, expanding all this is gonna be a pain in the butt. No, it won't. Actually, it won't. Um, this will be 4 cos squared. I'll pull out the 4 here. And this is just 1 plus 4 sine theta plus 4 sine squared theta. And that's just cos squared theta d theta. And then from there, from there we can expand it and simplify it. Because, or expand the parentheses, then simplify the whole thing. So, cos squared theta plus 4 sine theta cos squared theta plus 4 sine squared theta cos squared theta d theta. Wow, that's so cool. And then I guess double angle identities here. Cos squared theta is equal to 1 plus cos 2 theta, I believe is right. What am I doing? Just write a 2 theta. Or no, I do need parentheses for that. And then cos squared theta sine squared theta, or sine squared theta cos squared theta, I guess sounds cooler, is equal to 1/4 sine squared theta. Sine squared 2 theta, sorry. And from there, we can apply another rule, or we can simplify 1/8 1 minus cos 4 theta. Okay, that's really, I don't know why I didn't pick up the pen there. And then from that, we plug it in again. Am I solving this wrong? Because I don't think I'm going to get the same answer as I did originally. Or no. I think it might be in a different form. Because this is a really, like, this won't get me all the other ones I got, but it might give me different. I don't know if the two things are equal, though, necessarily, unfortunately. Oh well, we're going to have to guess. I guess I'll see it to the end before I go one last time before I have to go to bed. Um, over 2 plus 4 sine theta cos squared theta. Oh wait, no. What? I'm not plugging any of them in. I just did all that just to not plug them in. Why am I just copying the top? Or no. I was doing it right. I'm so dumb. Plus, I thought I was copying the top. I don't know why. I space out sometimes. Can't forget d theta. And then from there, simplify these things. Pull the 4 back in. I mean, to simplify those things, and that leaves us with 2 plus 2 cos 2 theta plus 16 sine theta cos squared theta plus 2 minus 2 cos 4 theta d theta. And then we just combine these twos to simplify it fully. Why did I just... What am I doing? I said I'd explain all my thought process, but honestly, I don't know. I don't know it anymore. I'm just doing what I think. I don't know what I'm thinking, I'm going to be honest with you. And now from here, first fundamental theorem of calculus, that's the first explanation I can really give. Don't know why I put a parenthesis there. Now we're going to start. We're going to do like, I'm just going to, like I don't got enough time because it's about to be 3 a.m. So I'm just going to write down the answers to each integral instead of going too much depth into each one. That should be that one. And then, yeah, 16 over 3 cos cubed theta. And then this one, negative 1/2 sine 4 theta, negative 2 sine theta cos theta times 1 minus sine squared theta. Or, yeah, because I can't just use 4 theta. Right? I can't do that. No, I can't. Whatever. We're gonna try it. And with that, yeah, we do plus c because there's still integration left. And now we have to go back to x. Sine theta equals x minus 1 over 2. And then cosine theta and then theta should just be arcsine. Yeah, something like that. So what am I doing? What squared? Now, this should be right. Should I plug it into the whatever you call it? The freaking Wolfram Alpha? I'm gonna do it on my phone. I have a phone for a reason. Okay, we're gonna plug it into Wolfram Alpha. Oh, that's gonna take so long to type in though, God. Oh wait, no. I have this whole thing. I have the thing I'm streaming on. What am I doing? Okay, open it up. Hurry up, I'm gonna open, please. Okay, there. Wolfram Alpha. Okay, oh God. Alright. Sort? No, square root. Mm, did I get this? Alternate forms. All showing tangent. I didn't get tangent. Okay, so I got this one wrong. Oh man, that's sad. That is a real bummer. Shucks. Oh well. I'm going to sleep. Good night.